Alright guys, this is the last lesson I will do before spring break. So this one is on solving exponential equations. Before we work anything out, let's look at these 8 exponent laws. You will probably think that you came across something like this on the formula sheet, but nope. If you have your formula sheet with you, have a quick look. Those are actually the laws of logarithms, not for exponent. So these are the things that you should have learned last year. Have a quick look. Alright, so if you multiply, then you add the exponent. If you divide, you subtract. And then if you do an exponent of an exponent, then you multiply the exponent. And then if you have an exponent for like outside the bracket, then you apply the exponent to each component inside the bracket. And then same thing here, except this one is for dividing, so one goes to the numerator on the top, one goes to the denominator on the bottom. And then the exponent of 0 gives you 1, right? And then with a negative exponent, that means you take 1 over. And the last one here is with the exponent of something over another thing. The top one, the one on the top, the numerator is the exponent, and then the one on the bottom right here is the root. Alright, so keep those exponent laws in mind. Now the next thing we want to do is to solve exponential equations. Alright, so when it comes to solving exponential equations, we always want to have a common base. What are the common bases again? So that's a base, that's also a base. So you can see that this one has a base of 8, this one has a base of 4. Of course, this is the exponent, this is the exponent. Alright, so the question says convert this and that into powers that have the same base. So that means your answer would look something like this. A base, same base for both of them, and then with the exponent like this. Okay, so now let's work this out. So when you look at this one here, 8 raised to the power of x minus 1, I hope you have a spidey sense that when you first look at 8, you know that you can write that as 2 raised to the power of 3. Okay, so if you still don't see it, never mind, I'll quickly show that to you. So look at this one here. So 2 raised to the power of 3, that gives you 8. And then outside it has an exponent of x minus 1. And then if you recall the exponent law that we just looked at from above, okay, then I hope you can see that we should be applying this one. Okay, exponent of an exponent, then you multiply the exponents. Okay, so in this case you multiply the exponent. That gives you 2 raised to the power of 3x minus 1. If you want, you can skip this step, but never mind. It's not too much extra work. This times that gives you 3x minus this times that gives you 3. So here we go, like that. Now let's look at the other one. Let me use a different color. So for this one here, again, I hope you have the spidey sense that tells you that you can write 4 as 2 to the power of 2, or 2 exponent 2. So in that case, it has the base of 2, and it's the same as this one here. So let's write this 2 raised to the power of 2. If you look at this, same base, 2 and 2 here, and then the exponent here is x plus 3. and then same thing, you multiply the exponents. So 2 raised to the power of 2 times x plus 3, and then you distribute this, multiply the exponents. So 2 times x gives you 2x, and then plus 2 times 3 gives you 6. Now if you look at this, these two exponents have been converted to something else that have the same base. At this point, you are just practicing this skill, converting an exponent into a base that is common to another exponent. Alright, so now we write as a power with a base of 3. So same thing, you want to have a base of 3 and then exponent, something like that. Okay, so let's do this one here. Now if you look at this, if we want to have a base of 3, so how can we write 3 with an exponent which equals to 9? So I hope you can quickly figure that out. So you can rewrite 9 as 3 raised to the power of 2. 3 squared is 9, and then you square that. After that, just like the last two questions, you multiply the exponent. So 2 and 2, so 2 times 2 gives you 4, so that means this is the same as 3 raised to the power of 4. This one is a good example, an exemplary type, so definitely pause it for now and then give it a shot. Alright, so next one here. You are going to write 27 in the form of 3 and then raise to an exponent. So I hope you can see that for 27, you can write that as base of 3 raised to the power of 3, or 3 cubed. And then outside that, you have the exponent of 1/3. Then for the second part of this question here, instead of converting 81 into a base of 3, I would manipulate the exponent first and then the degree of the root so that it looks more familiar with. Okay, so for me, I'm going to write this way. 81 and then raised to the power of 2/3. If you don't see what's going on here, this is one of the exponent laws that we talked about on the previous slide. So have a look. Okay. After converting 81 cube root of 81 and then square into this form here, I can rewrite 81 with a base of 3. Alright, so first part is still the same. So, well, or maybe we can actually simplify this at the same time. So 3, and then for the exponent, you multiply them. 3 times 1/3 gives you 1. Alright, that's the first one. And then for 81, you can write that as 3 raised to the power of 4. And then outside, you have the exponent of 2/3. Okay, so the first term is still 3. Second term, now multiply these two exponents together. 4 times 2/3. So that gives you 3 raised to the power of 8/3. And these two have the same base. And this one, if you want, you can write down the exponent of 1 here. Because the thing is, we are going to combine these two together. So by applying the exponent law again. So if you look at this, we multiply. When we multiply these two, since they have the same base, we can combine this base together and then simply add the exponent. So I have 1 plus 8 third. So 1 plus 8 third. So if you want to combine the exponents together, you can rewrite that as 3 raised to the power of 3 over 3 plus 8 third. Now, because they have the same base, we can just add the two fractions. So on the bottom we have 3, on the top we have 11. So here we go. Okay, next one, algebraically solve for x and check graphically. So let's do this here. You might be wondering, how do we solve this algebraically? You might want to pause and then copy down the notes. First step is to change to common base. So here the base is 8, here the base is 16. They don't have the same base, so make them having the same base. How? Just like the last few questions we did. After that, use all applicable exponent laws to simplify each side into a single base. Okay, so you want to simplify that. After you simplify, then drop the bases and solve the resulting equations. Okay, now let's do this. Have a quick look to see what is the common base. Again, I hope you have the spidey sense that the common base in this case would be 2. So let's rewrite 8 and 16 with a base of 2. So let's look at left hand side first. So left hand side, you can write that as, for 8, I can rewrite that as 2 raised to the power of 3. Okay, and then outside that I have the exponent of 3x minus 2. Okay, and then on the right hand side, 16, you can write that with a base of 2. So hope you all figure out that we can write 16 as 2 raised to the power of 4. Okay, and then it has the exponent of x plus 1. Now have a look, they have the same base, base 2 here, base 2 here. Now let's combine the exponents. So left hand side, 2, so distribute that. 3 times 3x gives you 9x, minus 3 times 2 gives you 6. And then right hand side, distribute this exponent inside the bracket. So 4 times x gives you 4x, so 2 raised to the power of 4x, and then plus 4 times 1 gives you 4. And now, as you can see, they have the same base. If this raised to the power of that equals to this raised to the power of that, because they have the same base, that means the exponent here, whatever that is, must be equal to the exponent here. So this is what I mean by dropping the bases. So that means 9x minus 6 must be equal to 4x plus 4. This must be the same as this, so that this exponent is the same. This expression is the same as this expression. Now, if you look at this, that's easy. After dropping the bases, it's just simple algebra. All right, so we can quickly solve that. Minus 4x, minus 4x. That cancels out, and then get rid of 6 here. Plus 6, plus 6, gone. So left hand side, I have 8x minus 4x, that gives you 5x. Right hand side, 4 plus 6 gives you 10, and then divide both sides by 2, so that means x is 2. So we just did it algebraically, graphically, that's easy. I hope this is a review for you in terms of solving this graphically. There are again 2 ways. I'll just talk about the ways I prefer. Plot this as one function, plot this as a second function. Okay, and then find the intersection point. That's one way. Another way is either move this to the other side and set this whole thing equal to 0, or move this to the other side and set the right hand side equal to 0, and then graph whatever you have on the other on one of the side, because the other side is 0. So graph that and then solve for the x-intercept, the 0 on your graphing calculator. Alright, so this one is just like the last one, except obviously much more complicated. So algebraically solve for x, so we are going to do the same thing. Convert all these into a common base first. So have a quick look. Hope you can see that the common base here would be 3. Alright, I don't expect you to see that. You can write an exponent with a base of 3 for 243, but like for 9 and 81, so I hope this one should be easy for you to spot. Okay, so let's do it then. So on the top, 3 squared gives you 9, and then with the exponent outside, x plus 6. And then on the bottom, 81, you can write that with a base of 4, sorry, with a base of 3. So 3 raised to the power of 4, because 3 times 3 times 3 times 3 gives you 81. And then with the exponent 2x minus 1 outside. And then on the right hand side, if you want, you can use a graphing calculator to figure that out. So if you write it as a base of 3, then 243 can be written as 3 raised to the power of 5. And then with the exponent 3x minus 4. Okay, and of course the next step is to work out the exponents, distribute that, distribute that, distribute that, or multiply them if you want to call it that way. So on the top here, 2 times x gives you 2x, and then plus 2 times 6 gives you 12, plus 12 raised to the power, sorry, I mean over, and then on the bottom you have 3 again, and before that I would put the brackets around because my handwriting is messy. For those of you who wants to play safe, or if your handwriting is messy, I would suggest you to put the brackets. Otherwise, if you, let's say if you have 3 square and then your writing is messy, so you may end up with writing 3 square like this, and then the next step you will think that, oh, it is 32. Okay, so distribute that. 4 times 2x gives you 8x, 8x, and then minus 4 times 1 gives you 4, minus 4 equals right hand side with a base of 3, multiply them through. 5 times 3x gives you 15x, and then minus 5 times 4 gives you 20. Again, put the brackets around to avoid confusion or confusing yourself. So most of you will probably think that drop the bases now because they are all the same, and we have distributed the exponent inside to the exponent outside, but nope, don't do that. So do not drop the bases until there is only one per side, because if you drop the bases now, that's an incorrect method. Okay, so we have only one base on the right, but we have 2 bases of 3 on the left. So let's simplify this. If you look at this, same base, this divide by that, so that means we can apply the exponent law because we do divide, so we subtract the exponents like this. 3 raised to the power of 2x plus 12 minus, because we do divide, 8x minus 4 equals, congratulations, you just screw up. Remember what I said before? Minus is nasty, so this minus applies to the whole thing, not just the 8x. So make sure you put the brackets around like this. And then right hand side, there's nothing we can really do. So we leave that as is. Now we can simplify this. So 3 raised to the power of 2x plus 12 negative 8x, and then negative negative positive plus 4 equals to 3 raised to the power of 15x minus 20. Alright, so let's simplify the exponents here further. So 3 raised to the power of 2x minus 8x gives you negative 6x, and then 12 plus 4 gives you 16 equals, right hand side, there's nothing we can do, so 15x minus 20. Alright, now because we have the same base on both sides and also one base on each side as well, so now we can drop the bases. Okay, so the exponent here should be this, not should be, must be the same as this. So drop the bases. Left hand side we have negative 6x plus 16 equals to the right hand side 15x minus 20. Okay, so if I were you, I'll put all the x on the right hand side, because in that case that would give me a positive x. So positive x on the right hand side. So plus 6x, you get rid of this, plus 6x, gone. And then get rid of the 20 here, plus 20, plus 20. These two cancel out. So right hand side, as expected, I would end up with a positive, I would end up with positive x, whatever amount I have. So in this case, 21x. And then right hand side, 16 plus 20 gives you 36, and then divide both sides by 21, 21, 21, gone. So that means x is, well, we can simplify this, 12 and 7. So that means x is 12 over 7. Alright? Alright, so the last two questions here. If you look at this, you will probably think you can write this with a base of 2, or you can write this with a base of 4. Okay, so should I write this as a base of 2 or 4? Let's look at this side. Think about this. Can you write this 1/8 with a base of 2 or 4? I'll just give you a few seconds. If you still have not figured it out, never mind. We will figure out something as we work this out here. Alright, so for this one, for 1/8, can I write that as 1 over 2 raised to the power of 3? Think about that. You can't really write this with a base of 4. So, okay, now what do we do? I hope you can see that we can write this as a base of 2, but if you look at this, this is not 2 yet. On the bottom, yes, it says it is 2, but then it's actually 1/2. Alright, so how can I convert 1/2 into, in quotation mark, 2? Well, by again applying the exponent laws. So you can write it like this. So can I write this as 2 raised to the power of negative 3? Think about that here. I would suggest, if you're still struggling with what I wrote down here, I strongly suggest you to spend some time going back to the Math 10C stuff to work out a few basic questions on exponent laws. Anyway, so let's continue. X minus 2. Now I can distribute the exponents. Okay, so 2 raised to the power of negative 3x. Negative 3 times negative 2 gives you, plus 6, like that. Okay, and then this one, I'll just move this. Alright, so let me use a different color. So since we figured out that the base would be 2 here, or the only base we can rewrite this is 2, so that means we have to use 2 as a common base here as well. So if you look at 16, we can rewrite 16 as 2 raised to the power 4 and then x. So 16 is same as 2 to the power 4 and then raised to the power of x. And then of course you can distribute that, so that gives you 2 raised to the power of 4x. The last one here is a little bit tricky because the thing is you're dealing with a fraction. Okay, so if you look at this, there are a couple different bases you can use. So I would go by this one first. So if you look at this, can I somehow use this as a base to write this 27 over 8? I'll give you a few seconds. Okay, so there are not too many choices here. You can either write this 27 over 8 with a base of 2/3 or with a base of 3/2. So either one way or the other. So a few more seconds. Hopefully you can see it this time. So if you look at this, 2 doesn't go into 27, 3 doesn't go into 8. But if you flip this, like this, so I'll use black here. If you flip this, when you flip this, you created an exponent of -1. Again, look at the exponent law. Okay, now if you look at this, 3 does go into 27 and 2 does go into 8. So that means we're on the right track. So hopefully you are able to finish the rest outside with an exponent of x minus 1. So same thing, because well, we already did the hardest part, figuring out what is a common base anyway. So distribute that. So 3/2 -1 times x gives you -x, and then -1 times -1 gives you +1. So done for this one. So for this one here, I'll give you a few seconds. How can I write 27 over 8 as a base of 3/2 raised to an exponent? Alright, so if you look at this, 3 and 27, hope you can see that 3 cubed gives you 27, and then on the bottom 2 and 8, so 2 raised to the power of 3 or 2 cubed gives you 8, and then on the outside 4 minus 3x. Okay, and then they have the same base, so we can they have the same exponent, so we can combine them. That becomes 3/2 with a common exponent of 3, and then outside that you have 4 minus 3x. Okay, so now just distribute this. You have 3/2 raised to the power of 3 times 4 gives you 12, and then minus 3 times 3x gives you 9x. So bingo, have a look. They now both have the same base, which is 3/2 and 3/2. So here we go. So you have this already. So I'll just quickly talk about this. Here are some of the questions you can try out from your textbook. I hope you don't find this session too hard. Alright, so I will see you later then.